you, babe. If it ain't love, why does it feel so good? Why does it feel so good?
Organizer of the next ICSC conference, I would like to briefly introduce Professor Edgar Vargas before his talk. Edgar Vargas was born in Colombia in 1972. And he got a PhD degree in chemistry from the University National Colombia in Bogota in 2001. Since then, he is a professor of Universidad de Los Andes in Bogota, and in 2014 was appointed professor titular, equivalent to the full professor. And his field of research is the determination of physicochemical properties of a solution. And he's edited also more than 50 publications related to the solution chemistry in renowned journals, and he directed, supervised 7 PhD theses. Actually, he is the head of the chemistry department and member of the faculty council as academic council of the University of Los Andes. Okay, today he will talk about this title, Physicochemical properties of Resorcin for Arenes in solution. Please.
Thank you, Professor, for your presentation. Thank you for the organizing committee for the invitation. I am going to talk about the physical chemistry properties of Resorcin for Arenes in solutions. The Resorcin Arenes are macrocyclic compounds. They are synthesized with resorcinol and the proper aldehyde in acid media. The Resorcin Arenes have 4 aromatic rings linked with an ethylene carbon, which corresponds to the carbon to the carbonyl group. One of the more important things to study this type of compounds is the conformation in solutions. The more common conformations in solutions are chrome, chair, bot, and silver. In our case, always work with chrome and bot conformation. This depends on the synthesis method. The more important is if we work in homogeneous conditions, that means don't permit that the product precipitate during the synthesized process, we obtain this conformation, bot and chrome, and sometimes they are in equilibrium. The Resorcin Arenes can be divided in 2 parts. The upper ring is composed by the aromatic ring and the hydroxyl groups, and the lower ring, which depends on the aldehyde that we use in the synthesis method. Now, with this, we have measured some thermodynamic properties in solutions of the Resorcin for Arenes in aqueous and non-aqueous solutions. Some of our work are with this type of compounds. In this case, we take the more base compound. We change the lower ring with alkyl chains, in this case with methyl, ethyl, propylbutyl, until exyl. In this case, we made a systematic study of this compound in solutions. The first was the solubility in water. These compounds have a low solubility, is 10-7 in molar fraction. The result was very interesting, that the solubility decreased with the temperature and increased with the number of the chains, in the lower ring. Is more soluble, the axial Resorcin Arenes, in respect to the methyl Resorcin Arenes. Then we calculate the solution enthalpies and the process results exothermic. Of interest in this case, we can functionalize with sodium sulfate, with formaldehyde, and we synthesize sulfonated resorcin Arenes. What is the advantage? That they are soluble in water. Of course, we measure some properties. The first question was, what is the conformation in solution of this type of compound? In this slide, I show you the NMR spectra from the tetrabutyl in chloroform. We can see this signal that is the signal of the proton in the position here. Then we can find only one signal, then the result is the one is only conformation, probably chrome conformation, or the equilibrium between chrome and bulk is so quickly that is the average for the conformation. But the more interesting was in water, the black water, and we can see two signals in the NMR. Here, and in the temperature, the intensity change. That means that in water, we can find two conformations in equilibrium. Of course, we can calculate the equilibrium constant for the change in the conformation in water. This behavior was found also in methanol and DMCO. Okay, then I show you the molar properties, standard molar properties in solution. Basically, they follow expected behavior. In this case, we have methyl, ethyl, and butyl at the end. But one of the more important things is the compatibility follows the same behavior because, is more compressible the butyl resorcin Arenes and is less compressible the methyl resorcin Arenes. That means that the compound with the larger chains on the lower ring is more compressible respect to the short chain in the lower ring. It's interesting that we don't change aggregation concentrations in water. But when we measure this compound in DMCO, we also found aggregation concentration. That means that in organic solvent, some organic solvent, that show aggregation concentration. In this case, is in this case, we change the third carbon of the butyl resorcin Arene by a sulfur atom. Okay, then we also compare the same group in the lower ring with different groups in the upper ring. For this, we synthesize this compound. In this case, is an anionic compound. Excuse me, cationic compound. The other compound was anionic compound. And the idea is to compare the results of this compound. Measure the butyl resorcin Arenes with some cations. In this case, I showed you the results of the tetramethyl ammonium and choline. The results was they form a complex 2-to-1. This is in this case we follow the complexation with chemical shift NMR. This is the relationship between the resorcin Arenes with tetramethyl ammonium, excuse me. In this case, we follow by two techniques. This is a speed of sound and chemical shift. And in both cases, we found that they form a 1-to-1 complex. Okay. The question was, what is the properties of if it's possible to complex these type of compounds with macromolecules like enzymes and proteins. In literature, we found a report that the similar compound to the Resorcin Arenes is calyx Arenes. The difference is that they are synthesized not with resorcinol, is with phenol. But it was very interesting that the sulfonato calyx Arenes have effect on the fibrillous insulin. In this way, we made some assays with the insulin and other macromolecules with biological interest, and we have some very interesting results. In this slide, I show you the insulin fibrillations with Resorcin. In the first graph, I showed you the black points is the control, is only the fibrillation of the insulin without Resorcin. And we found that when we compare butyl, propyl, and ethyl Resorcin, practically the propyl don't have effect on the fibrillation, but the other compounds inhibit the fibrillation of insulin in solution. When we compare the butyl Resorcin with the ethyl Resorcin, we change the carbon atom by sulfur atom, both inhibit the insulin fibrillation. Here are another examples. In this case, is methyl Resorcin, and we also synthesized a sulfonated compound, but in this in the lower ring. The effect was practically the sulfonate in the lower ring don't have effect on the insulin fibrillation, and this compound inhibit the fibrillation of insulin. In this case, we compare the cationic with anionic compound, which both inhibit the fibrillation, but the effect is lower with the cationic compound. Okay, with my colleagues, they made molecular docking, and they found that probably the site of binding is by the sulfur bridge with the amyloid. Professor Roger LeBlanc in the University of Miami, and Professor Buckner in Edgar University, and of course, the more important in my lab, that is my student. Thank you very much.
Okay, thank you very much. Now the time is open for questions, comments. Yes, please, come over here.
Nice talk, Edgar. Thank you very much. On one of the pictures, when you studied the bovine serum alloy, can you go back to that one, please? And when you studied surface tension, okay? No, I think this is just the surprising thing to me is that you work at minus 21 concentrations technically. How is it possible?
I don't know. This is the natural logarithm of concentration. Yes.
So it means that the real concentration was, so you had a few hundred molecules in solutions.
No.
Different.
No, this is only the natural logarithm. It's not the concentration value. Here, it's natural.
Okay, I see, but then it means that the concentration itself was something like 10 minus 20. And this is very small, as far as I'm concerned.
No, it's more or less 10 minus 4, more or less Probably I have a mistake, I don't know, but it's probably, but it's more or less,
Okay, maybe I
yeah,
mistaken it.
probably I have a mistake, but
Okay.
it's more or less that.
Okay, thank you.
Okay, any question? Yes.
Thank you very much for this nice presentation. I've been working in the past few years in the field of formation of amyloid fibrils, and I'm really amazed about your arene molecule that inhibited the fibrillization, because usually it is stated in the literature that only small molecules can do that. So I was interested in how large is this molecule?
Oh. Approximately, I don't remember the number, but probably in nanometers, the rallies, the underground rallies, I don't remember, probably, okay, no, I don't remember.
Yeah, it's okay.
Yeah.
I have another short question. We know that thioflavin T can produce also false negative results. So have you thought of maybe trying with Congo red dye also?
No,
Okay.
no, only when TST, yeah.
Okay, thank you.
Next again.
Sorry, I just wanted to add a comment.
Yes.
I can't remember how big these molecules are either, but the molar volume you might have noticed is around 600 centimeters cubed per mole, so they're big.
Thank you, great.
Okay. Okay. Perfect, Mark.
Brilliant talk, Professor Edgar. You had a slide on isothermal titration calorimetry.
Yeah,
What is the information we could deduce from the slide that you showed?
yeah. First is the energy of interaction between the enzyme with the compound. I don't know if it's probably to see how many molecules interact. I don't know, because it's very difficult because the molecule is very big. But the more important is the energy of interaction. Okay.
Thank you so much. Thank you.
Any other question? We've got plenty of time. Okay. If not, let's thank again for the nice talk. Thank you very much.